Okay, so let's take a look at it. We got 50 minutes. Let's do the best we can. So once again, this thing I'm going over right now is all on the web page under announcements with all the answers, but not all the steps. So that's why I'm going to do the YouTube, show you all the steps, much as I can in 50 minutes. Okay, so how do we do this first one? That's an absolute value graph. Yeah, we see all the absolute values there. But it looks like it's been moved right to... Okay, so what moves an absolute value equation right to? X minus. Remember, x does opposite? Remember, x is always opposite? So absolute value of x minus 2. But I don't see that there. Was that one none of the above?
No, it was A.
I'm having trouble already. Why? Okay, yeah, no, yeah, that's tricky. Boy, I was tricky when I made this thing. Okay, why is it A then? What? Why? I thought it was supposed to be this, and that's not what A says. Well,
The
yeah,
positive 2 makes it go back 2, and then the negative next to the x makes it flip across the
2 minus x is the same as negative x plus 2, first off. You agree? Remember, the order of things doesn't matter, just the signs in front of them. So you can shuffle things around all day as long as you keep the same sign in front. Hugely important lesson in moving on into calculus. You know that, right? So what's in front of this x here? Negative. What's in front there? Same thing. What's in front of the 2? Nothing. What's in front of the 2 plus? Same thing. So you see how these are the same, you agree first off. I'm not saying it's the same as that. Let me get that out of the way. But you agree with me that this and this are the same, right? Because all I did was trade the order. And that doesn't matter as long as you keep the sign in front of them with them. It's like their baby. You take your baby with you. So that negative stays in front of the x, positive, that's the same thing. So you can change the order all day long as you keep whatever signs in front of it with it wherever it goes. You haven't changed anything. So these are the same. Okay, so what? Well, what is that negative going to do on that x? What does negative do on an x in a graph? It takes it and flips it. What happens when you flip a v? If you got a v and you say, I'll flip it. Sideways, I mean. Flip it sideways, right? X is sideways. If you put a negative out here, yeah, that would flip it down because that would be a y effector. Remember that? Remember what we learned about x effectors and y effectors? Negatives in x's little world, like this one, is a sideways flip, huh? If you put a negative in the front, that would be a vertical flip. That's not what we're talking about. So that negative right there is just a sideways flip, does nothing. And of course we know that, huh? Negative inside of an absolute value, what does that do? Nothing. We see it both graphically, because if you flip a v, nothing happens. And we know the absolute value negative, you might as well just make that positive. That's the same thing as just positive x, right? What is absolute value? I'm scribbling it all up. What does absolute value do to a negative sign? Just gets rid of it, huh? So this is the same. That's tricky, huh? That makes sense? We all good with that? So you really got to know these little rules, huh? Is that okay? You good? Please speak up. I'm glad to talk more about it. Move on. Come see me. I'd be glad to talk more about it if that's confusing. All right. That one's some kind of an x cubed graph. They're all x cubed. What's been done to it? Well, what's the norm? What you should put on your 3x5 card is the normal one, you know, or maybe you just have them. There's the normal one, right? Y equals x cubed with nothing done to it, right? The normal one. It's good to have the base pictures, those 6 on your card. You know, there's the normal one. Okay, so that looks kind of like the normal one. Looks like they've just moved it up 6. Looks like, right? Up 6. And is that left 1? Yeah, it looks like there's some kind of movement on the sideways, so left 1. What's going to make you go up 6, left 1? Well, up 6 will be, and well, the left 1 is minus 1, no, plus 1, huh? It does the opposite for x, right? Opposite for left 1 is plus 1, and up 6 is plus 6 for y, that's up 6. So do they have one of those? X plus 3 cubed, it's A again.
I think it's left, right?
What's that?
You move to left to negative to there.
Oh, no. Oh, good question. I'm glad you brought it. It's where the origin goes, which is right here. Does that make sense? Okay, there, right there. So in other words, what they did, you can see that's where it does its little bending trick. So this origin is gone left 1, up 6. Now this other tail part is at 3, but that's not where the center has moved. You see, it's all about where the center has moved, right? The entire graph has been moved left 1, up 6. Yeah, don't be confused by the tail part. Does that make sense? You focus right here on where the center is. Good question. Does that make sense on that? Everybody see that? All right. You could also make tables. Yeah, let me help out. Some of these rules are tricky, aren't they? You know what I mean? Let me show you what I mean. Like back on this one. There. Back on this one for a second. If you're looking at this and we'll go back to the absolute value thing, you're thinking, I don't know, Mr. Heron's tricking me, he's doing all these negatives and stuff. You could just say, look, I know it's not B, because why is it not B? The plus 2, back to number 1 real quick. The plus 2, what would that do? What would a plus 2 outside the absolute value do? Up to, That'd be a Y thing. That'd be up to. It's not up to. It's just been moved right to. So I know that's not right. It's not absolute value of x plus 2, because what would the x plus 2 in the absolute values do? Left 2, because x does opposite. So it's not left 2. So get rid of that. It's not minus 2 outside the absolute, because that would go where? Down 2, because again, that would be a y that's outside of x's world. So you know it's not b, c, and d, right? A lot of times, process of elimination. You know it's not b, c, and d, so you're just thinking maybe it's e, maybe it's a, right? It's the only option. So you're thinking, is it a? If you're like, I don't know, all them tricky rules about flipping and stuff, I'm just going to make a table. Yeah, I should have told you that earlier. Just take, if you're thinking, I don't know, let me check. Is it that one? Just make a quick little table. You know the points that should be on there. Like, what is this point right here? That's over 2 up 0, right? You can tell just by looking at the graph that's over 2 up 0. Well, does that work in the table? If you put in 2 for x and 0 for y, does that work? Oh, yeah, that does. Okay, that's just one point, though. Let's try another one. What's another one? It looks to me like over 1 up 1, right? Right there. Over 1 up 1 should work. Does it work in the equation? Over 1 up 1? Yeah. Well, how about this one right here? How about this one? What is this? Over 2 up? No, 3. That's 3, huh? Over 3 up 1 there? I'm just grabbing some points that are obviously on the graph and seeing if they really work in A's equation. So 3, 1. Does that work? Put in 3 for x, 1 for y. Yeah, that baby's working. See how that's another way. If you don't want to get tangled up in all these flips and things, if you're just down to one option, well, I guess you could try that for all of them, but that's going to take a long time. I don't think you have time for all that. But if you can get down to just one option and you're like, I don't know, make a table with a couple points. If it's working, that's it. That's the answer. Does that make sense on that? So you can always do the table making thing. Oops, where am I at? All right, so number 3, square root graph. All right, so it's the square root graph. It's going left. So, right, the normal one starts at they all start at the origin, right? They all start at the origin. The normal one starts at the origin, goes right. That's the normal root x. So this one, what makes the thing go left? Where's the negative have to be? Inside, right? Not outside. Because inside, again, it's an x flip. It's a sideways flip. If it was out like this, if it was outside like this, that would make it go down instead of up. Everybody with me on that? Everybody see the difference between an x effector and a y effector? So first off, when it's in there with x, it flips left. If it was outside, it would flip down. So let's get rid of all these ones, like no way B. It's got the negative outside. See how it has the negative outside? They're just trying to trick us. No way A. That's a negative outside the root. That's his negative. Remember, that's his baby. Anytime there's a sign in front of something, that's your baby. You don't forget your baby, right? I forgot my 5th baby. By the time you have 5 children, I don't know, I guess, I never thought I'd have 5 children. You think you got it all figured out, so I brought my wife, this was years ago, 10 years ago, brought my wife home from the hospital. We always, have a little lunch together, just her and I, face to face, when the new baby comes, have a routine before we go home to the wildness of 4 or 5 children. So we're driving her home from the hospital, we got Abigail in the back, so we pull up to the restaurant, jump out of the van, start going in the restaurant. My wife looks, she's just funny. And she looks at me and smiles and says, do you think we should bring Abby or what do you think? I'm like, oh yeah, Abigail, my baby's in the, anyway, so you don't forget your baby, right? So it's signs in front of them, that's their baby. That's wherever they go, that's theirs, right? So when you look at that minus on that root, that's his, right? So that's a negative on root, that's no way, there's not a negative in front of the root. So A and B are out, right? C and D or maybe. C and D or maybe. Let's take a look. So what do we need? A negative on the root here. I'm sorry, on the x in the root. So C's out. Look, he doesn't have a negative on the root. I'm sorry, on the x. I keep saying the wrong thing. Right? C is out because, look, there's no negative there. So look, it's either D or E, isn't it? Only D has a negative on the root. No, on the x. I keep saying that backwards. Only D is even a possibility right now. You with me? Because he's got a negative on the x that's in the root. If that bugs you, now I did a lot of these backwards. I'm not trying to torture you. I want to get you ready for calculus. You need to get comfortable, and I'm here to help. Please come see me, see Roberto, and I'm doing all these YouTubes and stuff so we can help. Do you realize that's the same as this, right? Just switch the order, take their baby with them, right? Wherever you go, you don't leave your baby behind unless you're a dumb dad. So you take that minus with it, right? That minus is on the x. So that's the same thing. Maybe that's easier to look at for you. It makes more sense. That's the same thing, right? So yeah, you go, oh yeah, that's going to flip it left. Okay, and then what's the plus 5 going to do? Oh, that's confusing. Shouldn't that be left 5? But plus 5 is right 5? That's backwards. It's a trick one. Remember the stuff that I told you about the order mattering? Yeah, before I go into the deep story, do you know what I would do at this point? Make a table. Don't be so overly confident. Here's why. Basically, you guys are probably thinking, no, that's not right. The answer is D. It's wrong. It is D, and it's right, and I'll show you with a table. But why, Mr. You told us plus 5 means x is opposite left 5. That thing's going right 5. Yeah, but it did it before the flip. Remember, the order matters, right? If I take a square root graph, okay, and I do x plus 5 first, which means what? Left 5. 1, 2, 3, 4, 5. I agree. That means left 5. It's sitting right there like that. And then I flip the entire graph. Remember, the flip is not a stand-in-place flip. It's a grab this thing like a rotisserie and flip it. What happens? The graph goes whoop over there, just like that, when you put a negative on that. You see that? That makes it end up going the other way, even though it was a plus 5. You guys see that? So you can't rely too heavily when there's when there's two things happening sideways, a flip and a movement, or two things happening vertical, a flip and a movement. It's pretty tricky. I would make a table. So we know it's either D or nothing. You agree with me at this point? Let's be a little careful about the plus 5, left 5, right 5, because we have a sideways flip. Rather than, I just said a big thing to you, but, well, how do you know? Because you might be thinking, if I was you, I'd be thinking, well, how do you know, Mr. Aaron? How do you know if you move it left 5 first and then flip it? Yeah, it'll end up over there. But if you flipped it first and then moved it left 5, it'd be here. So the order matters. Right, I know, and it's totally complex. And I told you once the story. If you really want that story, come upstairs. I'll tell you more. But I would not rely upon that because it's pretty complex. I mean, I could give you all the details, but it's complex. Instead, I'd make a table. Table's way easier, right? So everybody hearing me on that? When you see this, you go, I don't know. It's one of them tricky things. I'm going to make a table. It's either D or nothing. Let me see if it's D. I'll just do a table. 5 minus x minus 2. Is it right? What's this point clearly? Over 5 down 1, right? Or 2? Yeah, 1. Down 2. Looks like down 2, I guess. Over 5 down 2. You can tell because they all have 2's everywhere. Over 5 down 2, right? You with me? I'm going to see if that works in that equation for D. Let's check it out. If x is 5, is y negative 2. Yeah, look at that. It's perfect, isn't it? 5 minus 5 is 0. Minus 2, yeah, y is negative 2. Well, okay, does it go this? Can you not, is this a no-fly zone? Can you not go to the right? Can you not put in things like 6? Yeah, exactly, because that'll make the inside of the root negative. Can you put in things like 4 and 3? Yeah, you sure can, 3 and 4, because then you'll get other numbers that seem to be working. Yep. If you want to do another, you have to use your calculator if you're not sure. That's probably sure enough, right? If you want to be 100% sure, plug in something like 4 if you want. If you put in 4 for x, you're going to get root of 5 minus 4 minus 2, which is root of 1 minus 2, which is negative 1. So does that look about right on the graph? Over 4 down 1. Yeah, it looks like it's right about there, doesn't it? See, right there, over 4 down 1. See, it is D. It is D. Is that okay? I know that's pretty confusing. This is pre-calculus, and we're getting you ready for calculus. We're not playing games here. This will not come to the casual. It's a good point in time. I've been talking this way to my sweet little daughter who's taking calculus right now, and she's trying to do some social stuff. I'm like, honey, you got to make your choices. We can't be spending a lot of time socially if we're going to do these hard math science classes and play on the tennis team. It isn't all going to happen. You really have to decide. You want to do pre-calc and calc? This does not come to the casual. This takes hours. She's just getting used to high chemistry and calculus, and she's like, it's crazy. I take this lab class. I spend hours of my life, and then this GE is only 3 units, and 3 units is a piece of cake, right? Welcome to math science. That's what I say to her. That's the truth. So this is a 4-unit class. It'll take like the time that 3 GEs take if you want to get the same kind of grades. What it did for me too. I'm a math guy, right? Just came to me while I rested on the couch. No. Math does not come to the casual. So I really encourage you, if you want to learn this, you want to do well in 2 days, you got to spend hours. I did. Hours and hours and hours mastering all these details. If you want to go the road of math science, you won't be disappointed. All right, so how about this one? I'm using up all of our time. How about that one? Which one is that? That one's easier, huh? That's just B, isn't it? Yeah, just goes left. Right, the negative on the root. That's an easier one. That's nice. Those other ones were painful. All right, piecewise. So, how do we do that? Which one is that? That's kind of hard. These are all kind of hard. Let's see. So, I don't know the best way to start. We could start this. Here's x values between 0 and I don't know what it looks like. Well, just 0 and onward. So the x value is 0 and onward, which would be like greater than 0, right? Not this. This one stops at 3. That's weird. The graph doesn't stop. Just forget option C. Right away. They have the graph stopping at x is 3. Remember how these conditions work? These things off to the right are the x zone, right? Saying it does this in this zone. Well, it doesn't stop at 3. I'm looking at it. The graph goes beyond 5. Right? It doesn't stop at 3. That's ridiculous. Hope that wasn't the answer. What's the answer on this one? It's B. Okay. Anyway, so yeah, it's not C. That's silly. D, maybe. X greater than 0. What does it do? What does this kind of piece do? I don't know. It's hard to tell exactly. How about this? I can. It's a positive slope line. These are all positive slope lines, aren't they? When x is greater than or equal to 0. It's a positive slope line. So, is it 3/2 x or 2/3 x? I don't know. It's kind of hard to tell. It's kind of hard for me to tell which of those it is. But I bet I can get more information on this guy. What's this guy doing? He goes up 4 and over 3, doesn't he? See how he goes up 4 and over 3? So his slope is 4/3 for the left guy. Who has a 4/3 left guy? This one? It's B. We're done. That's enough. See how I got it? The only one that has B and C are the only ones that have 4/3. And it isn't C because he stops at 3. So it's B. We good there? I guess there's the none of the above. You could try to be even more careful. But there's just so much time you have, You could check it more. It is 4/3 x plus 4. You could plug in points and see if they work. I don't got time. You could plug in 0, 4 and see if it works, and -3, 0, 0. See if you put in 0, it is 4. That's true. And anyway, we got to move on. It is B on that one. Is that okay? A little better. So these are all in the part where you can use a scientific calculator, but not a graphing, right? So number 6, 6 less than or equal to 2/3 x plus 4 less than 12. All right, so what do we do for that thing? What do we do with fractions? Get them out of there. By multiplying by the denominator, huh? This is like 3 sections. Multiply through by 3 all the way across. Right? Cancels here. Get 18. This is 2x plus 12, 36. Good so far? So I multiplied through by 3. Now, let's keep going. Now we want to get, our focus is right here where x is. X is saying, I want to be alone. So get rid of that 12. all the way across. And this is gone. We get 6, 2x, 24. Last step to get x alone. Divide through by 2. And we get 3x, 12. There it is. Between 3 and 12, it looks like it's answer C, huh? You good there? Questions on that one? No mistakes yet. I just made this thing this year, so I'm looking for mistakes. None yet. Good? So I'm going to move on. So I'm purposely giving you fractions and denominators to help you get ready for calculus. These need to be easy for you to have any chance to pass calculus. Calculus is much harder than this class. Okay, so what do we do with fractions? Common denominator, 3 times 7, 21, right? And you don't need both 7s. Remember that from your algebra days? You know, a lot of what we do here is master algebra. I know you had algebra and you learned it and you passed, but we master it. LCD is just 7 times 3. You don't need to repeat both 7s. It's just 21. It's just one of each type. One of each type. So 21. So 21, 21, 21. Here's the wall. What happens? You cross cancel and multiply what's left over. 7 into 21. 3 times, that 3 goes boom, boom, because he's left over. 12x plus 15. Good so far? 7 into 21, 3 times 2 is 6. 3 into 21, 7 times 7 times, negative 7 times 7, negative 49x. We good? So there, got rid of the fractions. That's always nice. All right, let's keep moving. What now? Well, we don't want x's on both sides, do we? So I'm just going to get rid of this one. You get rid of the other one. It doesn't matter. Just get rid of somebody. I think you know. And 15 and 6 is 21. Huh? This is minus, what is that? 61? Am I doing that right? Yeah, 61. And last step is divide by the minus 61. 21 over minus 61. Is it not there?
Nope.
Is that none of the above? Yep. There it is. There are some none of the aboves. Trying to keep you honest, make sure you're not just guessing, but you're really solving. Sorry, I know it's disturbing, huh? You do all the good work and you're like, where is it? Sorry, I'm not wanting to disturb you, but got to do that. Is that okay? Making sense? Okay. Keep moving. You know, the real exam, you're going to have more time. The real exam, you'll have an hour and 15 minutes. I only gave you 50 minutes today because I wanted to go over it. So real exam on Thursday. I'll come to class. I'll lecture on new stuff, which I'm sure you'll wish I didn't do, but I'm sorry. I got to keep the boat moving. I'll lecture for 35 minutes on something new that's not on the exam, section 4.1, and then I'll pass out the exam, well, part 1. And so you'll end up total time hour and 15. So I'll give you an hour and 15 minutes, 75 minutes instead of just 50. So that's 25, so half again as much time, basically. Another 25 minutes. Yeah, so you'll have more time. I rushed you today. But still, make sure you are fast. It'll be the same size as this, exactly the same number of problems, same type of problems, just different numbers, you know. Well, not, yeah, I mean, I might mix it here and there, but it's basically the same thing. Okay, so how do we solve number 8? 4x squared is 10 minus 3x. What do you do with x squared equations? Remember the strategy? For x squared with an equal sign, step 1 is get a 0. Remember that? And then factors with parentheses. So I'm just going to bump these guys to the other side. They change sign. 4x squared plus 3x minus 10 equals 0. Good so far? Get a 0. Now you got a factor. Or you could do the quad, right? I'll just say or. You could do the negative b plus or minus the square root of b squared minus 4ac all over 2a. Either way you want to go. A lot of people like the quad better because factoring is not always the easiest thing. Whatever, maybe I'll show both ways. So if you want to factor, I just do the FOIL thing. I just write the word FOIL and just make it work. There's all kinds of good ways. 2x, front times front to make front. I'll just do that, right? 2x times 2x. Front times front's making front. Could it have been 4x and regular x? It could be. I'm just kind of guessing at this point. It's usually, though, numbers closer together. So for 4, what multiplies to be 4? 1 and 4 or 2 and 2? Which option should you try first, 2 and 2? It's usually the numbers closer together instead of the numbers further apart, but it could be 4 and 1. Anyway, I'm going to do 2 and 2. Oh, it's not 2 and 2. I know for sure it's not 2. It's going to be 4 and 1. How do I know? Because now I'm looking at the L, the last, 10. What times what is 10? 2 and 5, so I could put a 2 here and a 5 here. No way. No way you're going to have two numbers in the same parenthesis that have anything in common, let alone the very same number. Do you remember that from your algebra days? You can't have two 2's in the same parenthesis. Why not? Because you can factor out a greatest common factor of 2. Well, so what? Well, then if there's really a 2 in common, we would have seen it up here. What? There is not a 2 in common. 3 doesn't have 2 in common. So there was never a 2 in common before. How could there be a 2 in common later? No way. So it can't be two 2's in the same parenthesis. So you okay, we'll switch them. Maybe the 5 will be here. Well, you see the problem. Then it's the same problem. Two 2's in the other one. No way. Well, okay, instead of 5 and 2, it could be 10 and 1. Yeah, but then you get 2 and 10 have 2 in common. So nothing works with 2's in the front. I'm not even going to go on with it. So I'm going to go, okay, it's got to be 4x and 1x then. So I'll go, it's 4x and 1x, or just x, right? That makes 4x squared. Now the 2 and the 5. But I'm not going to put the 2 there, because 2 and 4 would have 2 in common. No way. Put the 5 here, the 2 there. That's probably it. How do you know for sure? Check the OI, which means what? 2 inner, 2 outer. O stands for outer, outer, I for inner, inner, right? 2 inner make 5x, 2 outer make 8x. Look at that. How can they make the middle of plus 3x? Plus 8 minus 5, right? So the minus goes there for the minus 5. The plus goes there. 2 times 4 is 8. There it is. It's factored correctly. I'm basically foiling in my head or with my little arcs and stuff, right? I mean, if you're not sure, if you're looking like, well, I don't know, you just got to practice foiling. I'm telling you, there's no shortcuts for math and science. You got to foil this out so many times that you can pretty much look at it and foil it in your head. If you're not there, you got to get there. You just got to practice and practice and practice until you can do that. That's basically what I'm doing here. So then set each one equal to 0. The first one is 0. The second one is 0, like that. Right? Because the two things times to be 0. Either one could be 0 to make that happen. Jump that to the other side. Jump it to the other side. 4x is 5. Divide by 4. So negative 2 or 5/4. That's D, huh? Negative 2 or 5/4. Now, having said all that, a lot of you will prefer to do the quad, which is fine. Let me go over here and do the quad. 4x squared plus 3x minus 10. So 4x squared plus 3x minus 10. Let me just redo it real quick with the quad. Negative b. If you don't like factoring, I know a lot of people don't like factoring. Negative b plus minus square root of b squared minus 4ac all over 2a. Okay, plug it in. You know the ABC thing, right? Sometimes this is easier. ABC. So negative 3 plus or minus square root of b squared. We'll get the same two answers. Minus 4 times a times c all over 2a. So what's that? Negative 3 plus or minus square root. What's that? 9. Negative, positive, negative. It's going to be positive 160 over 8. Choose your calculator. You can use the scientific calculator on this part of the test. It's 160. So that's negative 3 plus or minus the root of 169. That's 13, isn't it? Negative 3 plus or minus 13, right? The root of 169. Right? We good so far? So now break those into the two possibilities. Negative 3 plus 13 all over 8, and negative 3 minus 13 all over 8, right? Which is 10 eighths, reduce it, 5/4. This one is minus 16 eighths, reduce minus 2. Is that right? Was that the answer? Minus 2 and 5/4? Oh yeah, it was. So that's probably easier for a lot of people instead of factoring. That's fine. We good? Either way you prefer? Mm-hmm. Okay, so how do we do absolute value? Well, I hope you wrote these on your 3x5 card because they're pretty tricky. They trick a lot of people. You want to know absolute value. This is, remember, we do something different for the less than we do for the greater. This is exactly what I'll give you on the real exam. I'll give you one greater, one less. In fact, there might be one other one. Probably just these two, isn't there? Yeah, it's on those. One greater, one less. Yeah. So the greater are the kind you break into the two. There's a greater number of statements. So that'll be this one. The less, you have one compound statement with the x in the middle and the two things. I'll show you. So this is the greater. So for greater, and greater or greater than equal to, same thing, whatever. Greater, what do? You do opposite. Here's a way to help you remember it. Opposite, opposite. What do I mean opposite? Turn the symbol the opposite way and take the opposite of the 3. And the other one, 5x plus 2, same Same. You write this on your 3x5 card. Keep the symbol the same, keep the number the same. Put an or in the middle. That's the removal. Remember, I always call it the removal stage. I want to, because I've noticed over the years students get confused. Notice I've removed the absolute values. That's the most important step. The rest is cake, right? It's correct removal of the absolute values. And see how that pulled them off correctly. That's what you do for greater. You do the two separate statements, and then you just solve it from there. Minus 2, 5x is less than minus 5, divided by 5. X is less than minus 1, this one, subtract 2. 5x is greater than 1, divided by 5. So x is greater than 1/5, less than negative 1. Right? So how do you say less than negative 1? That's from negative infinity to negative 1. How do you say greater than 1/5? 1/5 to infinity. So, what is that? That's B, huh? Does that make sense how I went? Greater, here's something that can really help, guys. The greater always is going to have a greater number of symbols. I mean, it's got to be A or B. Forget C and D. Or E. I guess it could be E. Do you know what I mean? Greater, absolute value greater. I mean, absolute value greater will always have the two parentheses. No way it can be C and D. If you just know that much, you know C and D are a joke. And then on number 10, that's a less. So less, it's got to be A or C. No way on B, no way on D. Or it could be E. Right? Because it's a less. It's absolute value less. It's got to have less parentheses. Not the greater. Everybody with me on that? That'll eliminate it down real quick. At least you know that much. You make a good guess if you run out of time. I'll finish it in a second. But is everybody aware of that? So the greater always ends up with the two things. The less with the one. You know, so put an example of one of these. Just put what I just did right on your 3x5 card. I kind of say that for everything. That you probably run out of room already. But you can put an example of a greater, an example of a less. You know, the greater always ends up with the two. So right away, you know, and then we got it. It's B. Let's do the next one. Let's do the less. So this is, if I'm going too fast, this will be on YouTube later. So number 10. So absolute value x plus 2 plus 9. Okay, what are you supposed to do first?
I'm guessing put the 9 over on the floor.
Yeah, exactly. Before you can remove, you got to get rid of that 9. You got to get the absolute values alone. That's exactly what this question is testing, if you're aware of that. Like that. Like good. Now do the removal. Once you got it alone. And what are we going to do? It's less. So what does that mean? I'm not going to make two separate statements with an or. I'm going to make the triple compound. What does that mean? Put the x plus 2 in the middle, put a negative 4 over here, and a positive 4 over there. And which way do the symbols go? Both less. Both the same as the original. Because that's what in the middle means, right? Like ordering a soda. A small is smaller than a medium, and a medium is smaller than a large. Right? Smallest, medium, large. Right? Small is smaller than medium. Medium is smaller than large. That's what we're saying. We're saying that X stuff is in the middle. So this is the triple kind. So how do you finish it? Subtract 2 now. So we get minus 6. There it is. Between minus 6 and 2, it is C. Option C. Hey, I'm not looking to trick you. I'm really not on the exam. I'm just learning to test. So notice, I'm not going to do weird stuff with the brackets and the parentheses. You can just know that up front. I'm not going to like give you minus 6, 2 and go, ooh, it was actually a parenthesis on the left side. You didn't notice. That would be dumb. I think that would be dumb. So I did not do that. So I'm just testing, are you really getting the big ideas? Not little silly stuff you might not notice, a tiny little parenthesis versus a bracket. So don't even look close at that. I'm just telling you up front. I'm not going to mess with you that way. I'm not looking to trick you. Is that good then? So don't worry. It's the bracket thing is right. Minus 6, 2 is the answer. Good? No questions? All right, I'll keep moving. We're to number 11. The graph, so we're not even halfway. Graph of a function. All right. Even, odd, or neither? Neither. Yeah, this one's actually neither. Now, you might think, wait a minute, you said like if it's like, yeah, if it went right through the middle, then it would be odd. That would be odd, but this one misses the middle. It misses. So it's neither. Do you know what I mean? It's got to be right smack in the middle so that if you turned it halfway over, right? Because it's called origin symmetry. It's got to be like if you put a pin down there and you rotate about the origin, it would go back onto itself. It would not. Would it? It's off a little bit, so it's not symmetric. So it's neither on that one. Number 12. Does that make sense? If they did this, it would be odd. Oops, I mean, if they did that, it would be odd. That one would be odd. But they didn't. They got it off. All right. So let's try number 12. How do you take a function now? We got a picture, even, odd, or neither. Now, how do you take a function, even, odd, or neither?
Replace x with negative 1.
Yeah, we stick in negative x. Remember that? Put in parenthesis negative x, and then simplify. Remember that? Simplify. Look back at the notes. You're accused of that. And if the new is equal to the old, that means even. And if the new is equal to negative 1 times the old, that means odd. Otherwise, neither. Remember that? Stick in negative x, simplify, and see what you got. So let's take this function and go, okay, it's negative, and then negative x cubed over 6 negative x squared plus 9. So if we try to simplify that, what's going to happen here? We're going to have, how many negatives up here altogether?
4.
4, right? 3 negatives and 1 more is 4 negatives. Is positive on the top. So that'll be positive x cubed. And this just goes away. 6x squared plus 9. So this is the new. How does this compare to the original? So the new, after simplification, right, put in negative x, simplified. How does this compare to the original?
Negative formally odd.
Yeah, it is, right? Everybody see that? The only difference, this one, the original here, is negative x cubed over 6x squared plus 9. That's the original, right? It's got that negative. So notice if you took the new and you multiplied it by negative 1, that negative will go right to the top. Remember, with a negative on a fraction, you don't do top and bottom. You just do one or the other, as we talked about, right? So it would just go to the top. Yeah, this one's odd. It's odd
It's an odd one.
because it's negative times one of them is the other one. Is that good? On that, those are. So this is our last section of homework we just had. What was it? 2.6? 2.6? Yeah. 2.6? Yeah. So basically you're taking the box, cut the corners out, fold it up into a box thing. So we're supposed to do the volume. They want the volume. Well, what's the volume of a three-dimensional box? Length times width times height. So what is the width of this thing? Well, it's all the way across here. What is that?
25.
25 minus 2x. It's 25 all the way. Whoops, so I'm not doing this very well. Bless you.
Thank you.
Inner edge to inner edge is 25 minus 2x, huh? Right? Remember how we did that? It's 25 outer to outer, back up x, inner to inner. Right? When you cut out these corners and fold them up, it's 25 minus the 2x's that you cut out, right? Because you cut out this piece and cut out that piece and fold them up. So the new box, after you fold it up, is not as wide. It's 25 minus 2x. And the height from inner to inner here is 13 minus 2x, isn't it? Right? So this is 13 minus 2x. This is 25 minus. And how tall is the box?
X.
And the height is the x, isn't it? Because that's what we folded up to become height. So length, width, and height, the volume statement, bring it down here. Volume is, and it doesn't matter what order you put these in. I'll just go 25 minus 2x, 13 minus 2x, x. And then you just got to FOIL all that out. So it's kind of a pain. So let me do that. Boom, boom. Oh, I don't know. I didn't remember my calculator. What's 25 times 13? 250 and 75. 325? I think it's 250 and 75. 325, right? Minus 50x, and then minus 26x plus 4x squared, all times. Let that x sit there for a minute. And you get 325 minus, what's that, 76x plus 4x squared, all times x. And then you distribute that x through, boom, boom, boom. and you get 325x minus 76x squared plus 4x cubed. Good. Okay, now what? Now put that in your calculator and graph it. Right? So now we would say, okay, y1 equals 325x minus 76x squared plus 4x cubed. Graph and find the max. So I don't have time to go through all that. Glad to help you in my office hours. Just graph that thing, find the maximum, and whatever the answer is here. What is it, A? I guess it's A. You find 2.72 is the x value for the maximum on your graphing calculator. Really, you know what, guys? You could have just plugged this in for y1 to save time. Yeah, you don't need to multiply it all out. I shouldn't have done that. Just put this in for y1. Your calculator can handle it. Right? You don't need to do all this. They're not asking me. Now, on the next one, they're asking me for all that stuff, so I'm going to have to. Number 14. But look, I didn't really need to do all this foiling and gathering like terms. If they just want the final answer off the calculator, just type this in. 25 minus 2x, 13 minus 2x, x. Just put that in for y1. Just make that y1. And hit graph and find the max. Make sense? No need to foil it all out. Let the calculator do the dirty work, right? Just like that. All right, I'll keep moving if you're okay with that. Okay, so, and then number 14, the distance. So we did those just last time also, right? How do you find the distance? Well, it's from to the 7, 1 to xy. Remember your distance formula? Square root of difference of x's. 7 minus x squared plus difference of y is 1 minus y squared. Like that. You got to FOIL it all out. If you FOIL, oh, and then, yeah, let me do this for a minute. And you could, if you switch the order, that's okay. If you have x minus 7, y minus 1, same thing. Remember, the order doesn't matter because it's just squared. And what is y? What do you put in for y? Well, this right here. Y is 2x plus 5. Plug that in right there. So 1 minus 2x minus 5 squared, right? The 2x plus 5, the subtraction negates them both, like that. So then we get 7 minus x squared, and this becomes 1 minus 5 is minus 4 minus 2x, like that. I'm going to turn around. It kind of bugs me to not have the x's in the front. It's fine if you're okay with it, whatever. I'm just going to go x minus 7, and this is minus 2x minus 4. Same thing. Doesn't matter. On that. And now just FOIL them. I'm going to go dot, dot, dot. You know, now just FOIL them out, gather like terms, whatever is the answer there. 14b. I guess it's B on that. Is that good? Distance formula. So put an example of both those if you have room. Is it hot in here today? It's a little hot. No? Sorry, it's just me. All right, anyway. So whatever you can put on your 3x5 card. 15. Hey, there's only 2 options. That's good. Function or not a function? Yeah, remember what we learned? Make something not a function. If you have y to an even power, so it's not if you have y to an even power or if you have plus or minus anywhere. Remember that? This is y squared. It's not a function. Because y 2 power, right? Even, 2 or 4, 6 on y. We don't care about x. So don't be fooled. On the real exam, I might give you x to the 4th power. Well, that's fine. That's still a function. It's only when y is to an even power, or if you have plus or minus anywhere, that it's not a function. Remember that? All right, number 16. Find the domain of the function. Number 16. Okay, so what do you do for domain? Remember, we take denominators, cannot be 0, and the root, the inside of any root, any 2 root, any even root, the inside has to be greater than or equal to 0, meaning not negative. Right? We just look for the 2 trouble spots. Remember I said you can't put knives in the toaster, you can't put tinfoil in the microwave, things you can't plug in. Well, you're not allowed to make any denominator 0, and you're not allowed to make the inside of any root negative. It's going to be greater than or equal to 0. So we don't care about the top. Top's got no problems. But the bottom, we go, oh, yeah. He's inside of a root. So the inside has to be greater than or equal to 0, because inside of a root cannot be negative. That means not negative, right? Greater than or equal to 0. But also, The 7 minus 3x is not only in a root, but it's also in a denominator. So it also cannot equal 0, so get rid of that equals option. It's got to be just greater than 0, not equal to 0, because it's a denominator as well as being in a root. Does that make sense? So then solve. So move the 7 over, so minus 3x greater than minus 7. Last step, divide by minus 3. What do we got to do? Flip the sign when you divide by a negative, remember? X is less than positive 7/3. Here it is, option B on 16. Hey, all the answers are right so far. First time I made this, usually first time, a bunch of wrong stuff. It's a little bit of wrong stuff, a couple options matched. Good so far? Is that making sense? Oh, look at. So 22, they're asking me to find the x-intercepts. How do you find x-intercepts? What do you do to find x-intercepts? Do you remember you set the opposite letter to 0 for intercepts? Because if you're at an x-intercept, say the graph goes boom, boom, and hits here and here. That means it's over something I don't know but up 0, huh? At an x-intercept, your y-coordinate, at both these, the y-coordinate is 0, isn't it? At an x-intercept, the y-coordinate is 0. At a y-intercept, the x-coordinate. If they want this y-intercept, this is over 0, up something, I don't know. Its x would be 0, huh? Do you realize that? At intercepts, the opposite letter is 0. Put that on your 3x5 card. I say that all the time. But maybe, if you still have room. So if they want x-intercepts, I'm going to make y 0. So I'm going to take this equation, 3x squared minus 5y equals 34. I'm going to make y 0. So that's just going to go away. You see, boom. So 3x squared is 34. So I'm not even going to use I don't even need my graph. You could graph it if you wanted to. But if you wanted to put it on the graphing calculator, you'd have to solve for y. Because you got to get y1 correct. Graphing calculator only has y1 equals, doesn't it? So you'd have to solve that equation for y. I'm just going to look, I'm almost there. Divide by 3. X squared is 34/3. Root it, plus or minus. Hit the buttons on your calculator. Plus or minus root of 34/3. But you can graph it if you want to. You can use a graph calculator for anything you want on part 2. If you want to graph it instead, that takes more time, I think. You'd have to solve for y, type it in, graph it, find the 2 places it hits. A little quicker to just go by hand on that one, anyway. Well, I wish I could do 25 with you. We're out of time. I'd love doing it in office hours. All right, guys, Thursday's the real deal. Study hard. You don't want to start off on a bad foot. Start on a good foot.